Tangent. All right, we're graphing tangent. The only thing that's happening is tangent is this -2. Now the negative is going to flip it, and the 2 is going to stretch it vertically. But I'm going to get you guys in detail how to graph a tangent. So the thing you got to think of, the thing you got to remember is that tangent is undefined at certain angles. So to help explain that, I'm going to pull out my friend right here, the unit circle. So tangent, since tangent equals sine divided by cosine, that means wherever cosine is 0, tangent is undefined. And so that means on our graph of tangent, we're going to have asymptotes where it is undefined, where tangent is undefined. So where is tangent undefined? Where's cosine, or the x value, equal to 0? And that is right here and right here. Okay, you guys got that? You got that? Okay, and so I'm going to use the angle pi over 2, and I'm going to use this angle right here. I'm going to go backwards. I'm going to use negative pi over 2. And so, as I mentioned earlier, guys, there's 2 strategies of graphing tangent. The first strategy is to graph it by using the center of tangent. The other strategy is to graph it by using the asymptotes. I think using the center makes more sense, so that's what I'm going to do. I'm going to use the center, and then I'll show you guys how to use the asymptotes. Okay, so, period. A period for tangent is pi. It is always going to be pi unless there's something multiplying to the x. So like if this was tangent of 3x, then now the period is going to be pi divided by 3. You always take the normal period and then divide it by whatever's multiplying to the x. But this one has nothing multiplying to the x, so the period is still just pi. The phase shift is 0. We have nothing adding to the x. If we had something adding to the x, then that would be our phase shift. So let's go to our graph now. Because we're not shifting left or right, we know that the center of our graph is going to be at x equals 0. The points where, the x values where tangent is undefined are going to be at pi over 2 and negative pi over 2. But I'm not going to write them yet because I want to come up with like a kind of a strategy to always be able to find your x values, because that's what we did with the other graphs. You guys remember that? We always had like this strategy to find all the x values. So that's what we're going to do here. There's 1, 2, 3, 4, 5 important points. We know the center, and we know that this is really only split up into 4 sections. So if from here to here is pi, how do we know the distance of every section? How would you figure that out? Take pi and do what with it? Divide it by 4. So I'm going to take pi and I'm going to divide that by 4. And so every section is 4. Pi over 4. Okay? So if I go this way, 0 plus pi over 4, what would this x value be? Pi over 4. And if I add pi over 4 again, what would that asymptote be? It would be 2 pi over 4, which simplifies to pi over 2. Hey-yo! Pi over 2, remember? Pi over 2 is where tangent is undefined. So if I go left pi over 4, what would that equal? Negative pi over 4. And then left pi over 4, yet again, would be negative 2 pi over 4, but we're going to simplify that dalge to give us negative pi over 2. Now we can graph. Now, some people are confused about the 2 points that I'm about to do. Now, to figure out these 2 points on this one, since it's our first time, I'm going to just plug them in. Let's plug in these points. These points will always be pretty points because, just think of tangent of pi over 4. What is tangent of pi over 4, people?
2 over 2.
Right here is pi over 4. What are the coordinates at pi over 4? Rad 2 over 2 and rad 2 over 2. So if you were to divide those 2 numbers, what would you get? 1. So what is tangent of pi over 4? 1. Okay, it'll always be pretty like that. It'll always give you 1. If you find the x value that's between the center and the asymptote, and you plug it in, it'll always be pretty. So, let's plug it in. Let's see the prettiness. Negative 2 tangent of pi over 4. Well, you guys know that pi over 4 is, our tangent of pi over 4 is 1. So what is negative 2 times 1? Negative 2. And so at positive pi over 4, we're going to go down to negative 2. There it is. You guys see that? Now, what about negative pi over 4? Okay, that's kind of weird. It's negative now. Tangent. Now, this isn't always true. It doesn't always make our answer negative, but in this case, it actually does. If I go tangent and I go negative, that would be right here. Is tangent positive or negative in the fourth quadrant? Negative. It is negative, right? And so tangent of pi over 4, while it is 1, we're negative 1 because we're in the fourth quadrant with our angle. We know which quadrant we're in because of the angle. So what is negative 2 times negative 1? Positive 2. So if we had our x and y chart here, pi over 4 would give us, what was it, negative 2. Negative pi over 4, that would give us positive 2. So let's put positive 2 on here. Now you have a graph. Just make sure your line is attracted to the asymptote. It's like getting closer and closer to asymptote. You got your graph. So let's transfer these points and these asymptotes over to the scaled graph. So we have an asymptote at pi over 2. I know because of my cheat graph. We have a center at 0. We have another asymptote at 3 pi over 2. How do you know that? I don't see that on my cheat graph. Well, what's the distance? What's our period? What's the distance from this to our next asymptote going to be? It's going to be the period. And the period is pi. So if you add the period to pi over 2, then you're going to get 3 pi over 2. And I'm going to show you guys the math on that really quick because I know some of you guys aren't thinking fractions really simply right here. If I have pi over 2 and if I add pi to that, that would be the same as adding 2 pi over 2 because 2 pi over 2 is still 1. And if I add those, I get 3 pi over 2. You guys will get better at adding fractions, trust me. I know. So I've been in your seat. All right, we got a center there at pi. We got a center there at 2 pi. And I just need to know the middle number between the asymptote and the center. See how I just found that right there? And I just put another one right there, and I put another one right there. For this one, I'm going up. Was it up? No, I go down. I go down the 2, and then I'm going to go up the 2 right there, down the 2 right there, and then this one's going to be up the 2. So now I can graph my tangent curves. Now because I stopped because the directions originally say stop at 2 pi. Now you could keep going, but we don't have to. Directions say graph from 0 to 2 pi. All right, so my range is negative infinity to positive infinity. And then we have a y-intercept at 0. X-intercepts, yes, we got those doggies. We have one at 0, we have one at pi, and we have one at 2 pi on my graph. And if I wanted to define all the x-intercepts would equal 0 plus, what's my period? Pi n. So we have a number of pi's adding to 0 to find our next x-intercept. See, check it out. What if n was 0? What would the x-intercept be? 0. What if n was 1? What would my x-intercept be? Pi. What if n was 2? What would my x-intercept be? 2 pi. And we can even do that the negative way. We can go negative 1. If I plug in negative 1 right here, my x-intercept would be negative pi. That would be whoosh, over that way, but that's not on our graph. All right, next we have our asymptotes. Our first asymptote is at pi over 2. Our next asymptote, actually I should say x equals pi over 2. And then my next one is at 3 pi over 2. And so if I wanted to define all my my asymptotes, I would start at pi over 2. And what's my period again? Pi n. And so we just keep counting by pi's to find our next asymptote. And that's how you graph tangent.